In the question above, we are to determine the amount of hydrogen ions that are contained in 100 cm³ of 0.40 mol per dm cube of H2SO4 6 acid. The first thing to do here is to determine the concentration of hydrogen ion in the acid, and from there we calculate the number of moles and finally the number of ions present. So let's write out the ionization of H2SO4 6 acid, that is H2SO4. So H2SO4 we ionize, we have hydrogen ion and H2SO4 6 ion. This has a charge of 2 minus, and to balance this we'll be having 2 moles of hydrogen ions. So now, since the concentration given is 0.40, that means the concentration of hydrogen ion equals to the coefficient here multiplied by the concentration of the acid itself, which is 0.40, and that will be 0.80, the unit mole per dm cube. So that is the concentration of hydrogen ion in the acid. Now that we've gotten the concentration of hydrogen ion in the acid, let's proceed to calculate the number of moles of hydrogen ions that will be present in 100 cm³. So from here, 0.80 moles of hydrogen ions is present in 1 dm cube, which is also equivalent to 1000 cm³. Hence, x moles of hydrogen ions will be present in 100 cm³ according to the question. So from here we make x the subject, so x equals 0.080 multiplied by 100 divided by 1000, and this is equivalent to 0.08, our unit moles. Now we've gotten the moles of hydrogen ions present in the acid, so let's proceed the final step now to determine the number of ions present, given the avogadros constant to be 6.02 times 10⁻23. So to solve that, we'll be making use of the formula saying number of ions or number of entities equals moles multiplied by avogadros constant. So here the number of entities here is number of ions, so we just say number of hydrogen ions. And meanwhile, entities could also be referred to as atoms. It could be the number of atoms, it could be the number of molecules, it could be the number of particles. Regardless, this is the formula that is, let's say, best or that is suitable to make the work fast. So now that will be equal to the number of hydrogen ions, the number of moles of hydrogen ions, that's 0.08 multiplied by the avogadros constant as given in the question, that's 6.02 multiplied by 10⁻23. So calculating this, we have 4.82 times 10⁻22, and our unit here will be ions. So if the entities is molecules, the unit will also be molecules, and this will be serving as the final answer. So with this, we've come to the end of the solution to the question, and we've gotten the number of hydrogen ions present to be 4.82 times 10⁻22 ions. Do it to subscribe for more if you find this video helpful.